everybody. Hey, I've actually never heard that before with this band. Yeah. Hey. You know, only in Cincinnati, Ohio, guys. It's a magical place. We're glad to be here. Thank you to Urban Artifact for having us. We got some more tunes, a few more tunes, a couple more tunes to play. Thanks to Devin for doing a fabulous sound job, and Michael back there too. You know, can't do it without you guys. Alright guys, once again, this is Luke Bergamini on the bass. Give him a round of applause, come on. He's working very hard up there. And wearing very short shorts. We have Willis Edmonton on the drums. Ben Hammer on the keys. My name's Graham Bloom, I play guitar and I do a little singing. This song is called Not Basketball. Thank you so much, y'all. If you guys are enjoying these tunes, they are available online. Don't get too excited. If you like what you're hearing, just look up Jeb Bush Orchestra on Spotify. We'll come to you. What? We got one more song with the Jeb Bush Orchestra. We're from Boston on our first tour.
Welcome everyone to Science on Tap. It's great to see some familiar faces. Thanks for coming out on this lovely June evening to learn a little bit about science and math. I promise that the math's not going to be scary, right? Okay. Science on Tap is a monthly educational program about science and critical thinking. We like to bring curiosity in the community together to have great conversations. So thank you for being here. We do this once a month on first Wednesday of the month. Thank you. And big shout out to our partners, Radio Artifact and Urban Artifact. And with that, I'm going to bring Austin up to the stage.
Hello, I'm Austin. I am a PhD student completing my dissertation at the University of Cincinnati in the classics department. If I say classics, what do I mean? Just to make sure we're on the same page. Yes. Yeah, so typically in a classics department, you might take classes in Greek, in Latin. I've taught Latin for several years now. So that's what I do. I am originally from the state of Georgia. I did my bachelor's degree in classics at the University of Georgia. And I came here for the first time to Cincinnati to do graduate school. I completed my MA in classics 2020. And the title of my thesis probably does not mean much to you. It's a bit much. I'll talk a little bit about some of these things on the next slide. And then, as I said, my PhD, I'm finishing my dissertation this, hopefully, God willing, this year. And somewhat a little bit more straightforwardly titled Ptolemaic Power in Hellenistic Poetry. So my interest is in the Hellenistic period. Not all Greek history is the same. It's divided into certain periods. Does anyone have any idea what the Hellenistic period is? Yeah, very good. Very good. So that is the period after Alexander the Great. Alexander the Great died in 323 BCE. And it usually, the end of it is kind of a little wishy-washy, but most people will date it to 31 BCE, which is when Cleopatra was defeated by Octavian's forces. And that was the complete takeover of the Mediterranean by the Roman Empire. So it is the period of Greek history in which Alexander's former empire is the dominant force in the Mediterranean, and that ends once Rome takes over. So that's the period that I study. So roughly 323 to 31. I'm interested in literature, specifically poetry, so Greek poetry. My master's thesis was on this guy called Callimachus. I have kind of secondary interests in Hellenistic science. So that Hellenistic period was a period of really great technological advancement in the ancient world. So there were quite a few scientific discoveries, one of which I'm talking about today. And I'm also interested in papyrology. So what I mean by papyrology is the study of papyri. And papyri is the material on which ancient Greek literature was written. They didn't have paper as such. Papyri grows on the banks of the Nile. You strip it into pieces, paste it together, and it becomes a material. This is an image of the kind of main papyrus that I'm working on that kind of inspired my dissertation project. It was discovered by a joint Egyptian-Russian team in 2019. on a mummy, and it was uncovered. It has to do with a festival program of different poetry competitions, and this was a really great interest to me as a literature historian, and that has kind of jump-started my project. And also epigraphy. Epigraphy is the study of texts that are inscribed into stone. So the picture that I have here, I spent about 6 months in Greece last year. This is a picture of me at the National Epigraphic Museum in Athens. And it's a stone that I did a project on, or on this time period. So yeah, those are my main research interests. So today we're talking about Eratosthenes. He was born, we don't have an exact date of birth, like many people from the Mediterranean, from the ancient world, but approximately 285. So, as I said, Alexander the Great dies in 323. So this is, within about 2 generations or so of early Hellenistic history in Cyrene, and I'll get to that. But I just wanted to say, so the Hellenistic period is very interesting, but an extremely complicated topic. If you are interested at all in the Hellenistic period, I would really recommend the Hellenistic History podcast. That is a QR code to the link. If you also want to get in contact with me to learn about it, you certainly can. But if you are interested to learn more, I would highly recommend this as a resource. So I don't really have the time or space to really do an in-depth conversation about Hellenistic history. But just kind of on a basic level, so Alexander conquered an enormous stretch of territory, the likes of which the ancient Mediterranean world had never seen. It stretched from Greece to India. Believe it or not, there were Greeks in India. And we know, for example, that there were Greek Buddhists, which is not something most people think about, but that was in reality the case. So it stretched from Greece to India and south through Egypt and modern-day Libya, through the Levant and Mesopotamia and everything in between. But after Alexander the Great died, there was a succession crisis. He had a little son, but he was just a little boy. His generals instituted a really complicated series of coups. That's why this history is really difficult to learn about. And his empire balkanized, you would say in modern political parlance. It broke up into numerous pieces that his officers took over. The big ones there were the Seleucid Empire, so you see that. And then you have some other ones. The one we're focusing on is the Ptolemaic kingdom. Anyone know anything about the Ptolemies in general? I can probably guarantee you know about at least one Ptolemy. She was the last Ptolemy. Cleopatra. Cleopatra was the last Ptolemy. She, notoriously, the Ptolemies practiced sibling marriage. That's probably their most infamous claim to fame. Not every generation did that, but that was a thing that they did. So the Ptolemaic kingdom is a lot of where our information comes from, and that's kind of going to be our focus today. So Eratosthenes was born in Cyrene, which I've circled there. That would be modern-day Libya. Born there in 285. At that point, it was, in this map, it is shaded as being part of the Ptolemaic kingdom, but that was about to change. It was already kind of up in the air. Ptolemy II's half-brother had kind of seceded and taken over Cyrene and that would be an issue, but theoretically it was part of the Ptolemaic kingdom, but not really necessarily. He received his childhood education in his home city, in Cyrene. But if you were a precocious child in the 3rd century BCE, and you had a lot of talent, you would go to Athens to complete what you could imagine is like having a higher education. There weren't colleges as such, but that was basically what that was. You would go to Athens. Despite the fact that Athens had been conquered by Alexander, it was still considered a major cultural center. So he went there probably around 270 or so. So that's Athens relative to Cyrene. And he studied under these two pretty obscure philosophers, Arcesilaus and Ariston. And he was very precocious, so he got a reputation very early on for his composition and poetry, and also scholarly writings. And he had amassed enough of a reputation in Athens that by around 245, this was Ptolemy the Third. So Ptolemy the First was Alexander's officer. He had a son, and then he had a son. So that's Ptolemy the Third. He was invited by Ptolemy the Third to become the royal tutor at the court and to become the head librarian at the museum. This is the famous Library of Alexandria. Oh, I'll get to that in a second. So, sorry. That's Alexandria relative to Athens. Alexandria is still the city, the second largest city in Egypt today. Ptolemy's museum, where he worked, it's not quite a modern museum in the sense that we have it today. The museum was a temple to the Muses, first and foremost. It was a place where people worshipped and conducted sacrifice to the Muses. I have a picture here of a still from Disney's Hercules. Very delightful depiction of the Muses, in my opinion. No, quite sincerely, I really enjoy it. But who are the Muses? They talk about it in the song. But what's their deal? Yeah. Right, exactly. So there's this sense in which poets have this kind of divine impetus in them that allows them to make this beautiful poetry or to be able to express deep truth. And the Greeks ascribed that to a divine influence that they called the Muses. And there were set muses for the various types of literature. So there was a muse of epic poetry, there was a muse of tragic poetry, and so Ptolemy had a museum that is a temple to the Muses. But a part of what that meant was that to honor the Muses meant doing research. So you honor the Muses by devoting yourself to what the Muses' role was. So the museum was not only a place where they performed sacrifice, but also what we would kind of consider a research institution or a think tank or something along those lines, but on, ancient terms. And it also had a library. So Ptolemy was extremely concerned with copying every book that the Ptolemaic port got. And so the Library of Alexandria was the most renowned library in antiquity. It is a myth that the Library of Alexandria just went up in flames one day and then we lost all this information. That's not true, unfortunately. I hate to break it to you. That's a myth. But it was still the kind of intellectual center of the Hellenistic world. It declined slowly over centuries. There were individual fires, but it did not take out the entire place. And in any case, it didn't result in a massive loss of information because everything that was in the Alexandrian library also had other copies in the ancient Mediterranean. So that didn't necessarily result in a complete loss of that text. Yeah. We actually do not have archaeology for the library because, the reason why we don't have much archaeology in Alexandria is a really complicated topic that has to do with 19th century politics and French and British colonialism in Egypt. That aside, we don't know where it is technically. This is a reconstruction of the Library of Trajan from the Roman period that we do have archaeology for. So it probably didn't look exactly like that, but because the Library of Alexandria was so prestigious, the Library of Trajan probably gives us a decent sense of what it looked like. So you notice there's a central section with tables where you would read, and you would have an enslaved attendant fetch you your book scroll. Of course, books were not folded books. They were scrolls on papyri in these massive book cases. The enslaved person would bring it to you. You would do your research, give it back. It also served a social purpose. They would have dinners that were done in honor of the muses, and they would have communal dining situations as well. So Eratosthenes is here. I'm sure he massively enjoyed this environment where every book that he ever wanted would have been there. And he was what we would today call a polymath. From what we know, we don't have much of his writings left to us. We know, for example, that he was the first person to call himself philologos. So philo, I love, logos, word. We got the word philologist from that, and I'm actually getting my PhD in classical philology. So we kind of owe that title to him ultimately. And as far as we know, from what we know, he wrote books on ancient comedy, books on geometry, a massive compendium of geography, philosophy, an epic poem, and that's actually just what we know about. There certainly was more than that, but he really produced a number of writings on pretty much every conceivable subject field that there was at the time. So at some point in his career, he turned to the question of what is the size of the Earth? So before I get into how he answered that question, a little bit of background on what the Greeks knew about the Earth. There had long been philosophical speculation about this. By the way, at this point in time, there is no distinction between philosophy and science. And in fact, until relatively recently, that was the case. Even the founding fathers of this country would have known science as natural philosophy, is what it was called. So that's actually a relatively modern distinction. So what we would call science was mostly done by what we typically call philosophers. One of the early pre-Socratic philosophers before Socrates was Thales, and he very famously said that the Earth is like a log floating in water. We actually don't have a great idea what he meant by that. Presumably he means that the dry land is kind of subsisting on an aquatic field of some kind, but it's very fragmentary. We don't have the best sense of what's going on there. But the philosophers over time developed some pretty sophisticated theories about the world. The Pythagoreans, you may remember your Pythagorean theorem from algebra in middle school, or geometry from middle school. Yeah, the Pythagoreans were the first to postulate that the Earth is a sphere. Contrary to what some people in our society believe, people have for about 2,500 years known pretty clearly that the Earth is round. The idea, first of all, that Christopher Columbus went out to the New World to prove that the Earth is round is a myth. It was a kind of an old wives' tale that was told beginning in the 19th century. It was not the case. Everyone knew that the Earth was round. And the Pythagoreans were the first to express this. Eudoxus, not too much later than that. Later than that. 200 years or so later, he said that the Earth is a sphere and that the other heavenly bodies are spheres that are rotating around it. So this would be a very lasting model, in the geocentric model. The Earth is at the center of the universe, and then around the Earth are these invisible spheres, and the heavenly bodies, like the sun, the moon, the stars, the planets, are kind of lodged in these invisible spheres, and all these spheres are rotating around the Earth. That would really kind of set the tone for how cosmology was conceived of in the ancient world after that. Except, there are a few guys, Aristarchus, who got a little bit closer to the truth and postulated that the sun was at the center of the universe. His theory did not catch on, though. He did his little wacky thing about a heliocentric model. Not many people took him up on that, and so the geocentric model really dominated until Copernicus. The Apollonius of Perga, another guy, this was kind of a modification. His idea was that the Earth is at the center of the universe, but the sun revolves around the Earth, but then the sun has the planets revolving around the sun. So he managed to, kind of blend the two together somehow. Very interesting. The most influential theory was that of Aristotle. This is a very complicated diagram of how Aristotle's cosmology works. Don't worry about it too much. It picks up on the idea of the spheres. Except that he has like 56 of them, because he also has to account for the zodiac. He has to account for the planets and the moon. So tally it all up, it ends up being 56 different spheres with all these different poles that are illustrated here. But this would really become the model that would persist through the medieval period, especially. Would not be substantially challenged until Copernicus. But it would be Ptolemy's Almagest that would come out in the 2nd century BCE that would really systematize the way to calculate the position of the stars and planets and the moon and everything based on this model. But he hasn't entered the picture yet. So that's cosmology. There's also geography to consider. So not just what is the Earth and what's around the Earth in space, but also what does Earth itself look like. We don't actually have these maps, long since disintegrated. But based on these people's writings, these are some kind of hypothetical sketches of what their maps probably look like. So here's one from the late 6th century of Hecataeus. Obviously, they had no knowledge of the Americas. The ocean is kind of considered to encircle around the world that they knew. Herodotus, also we know, so Herodotus was the first writer of history. He was the first historian in the European tradition. He was also a geographer, kept track of the geography of the places that he was talking about. And he also made this map, another reconstruction here. All things considered, not too bad, right? I mean, you can see what's happening there. They're pretty recognizable. Yeah. So the reason why it doesn't extend to China is it's questionable whether they knew about China at this point in the 400s. The Silk Road started to develop. They understood at least as far to India. Their knowledge of China was very limited. Throughout antiquity, they called China Ceres, which just means silk. Because literally all they knew about China was that that's where they got silk from. They didn't know much else about it. China is not going to feature a ton on the kind of reconstructions of Greek geography. Yeah.
So they have an idea that there's things outside of that upper boundary, but they're not totally sure what it is.
Yeah. So the same goes with Africa too, by the way. The Sahara is incredibly difficult to get past. And it means circumnavigation around Africa, which is just the resources it takes to do that is just really enormous. So European knowledge of sub-Saharan Africa really didn't improve all that much until the age of colonization and starting in the 16th century or so. So Africa too, below the Sahara, is kind of we'll talk about this, but eventually, because of the calculations that they did on the size of the Earth, they did understand that the world had to have been much bigger than this. So they would have been vaguely aware that they didn't have that information. They just didn't know what to do with it. Yeah. Yeah.
You mentioned Greek Buddhists in India.
Yeah.
Were there Greek colonists that were moving around in this area?
Yeah. Oh, sorry. I forgot I needed to repeat questions. The question was about the Greek Buddhists. It was not until Alexander's empire that there was direct contact, as far as I'm aware. Presumably there was before, but substantial contact between Greeks and Indians really didn't start picking up until Alexander's empire. Because Persia, the other great empire at the time was Persia. And Persia abutted the Indus River or so, but it did not conquer India. Alexander the Great finally got to India. Okay. So here's another. So there was something that happened in the 1940s called partition. India was bigger than India is today. So when I say India, maybe I should clarify, that is modern-day Pakistan. We are thinking of pre-partition India. So maybe that will hopefully clarify. The Greeks really didn't go so far down the subcontinent as that. So this would be modern-day Pakistan. Yeah. So sorry. So that didn't pick up until Alexander's empire. That was when that cross-cultural contact really became developed. Okay, so size of the Earth. So as we said, they have these theories about cosmology. They have some theories about geography. Now we're getting to the question of the size of the Earth. So just as a fact for ourselves, we know that the Earth is 40,075 kilometers around the equator, and 48,008 kilometers the opposite. So you can measure it around the equator, you can measure it from pole to pole. Notice the discrepancy. Earth is a little bit squashed. Just a little bit squashed. Now, this is how are we arriving at this? A tape measure. So if you think about it, this is kind of an impossible question because there's terrain, there's topography. I mean, are you supposed to measure every single divot and valley and hill? It kind of starts to get ridiculous after a while. So this is actually a mathematical model which produces this question. So I don't know the kind of physics and calculus or what have you to arrive at this. Please don't ask me. Presumably, there is some extremely complicated algorithm that is, uses the top-notch physics that we have with our knowledge of the composition of the Earth. Well, yeah, I mean, kind of, yeah. They have an algorithm, and based on our knowledge of physics, it produces a mathematical model, which then says this is the size of the Earth based on our knowledge of the physics and the composition of the Earth. So that's what we're doing. Now, interestingly, in the late 300s or so, Aristotle calculated the circumference to 44,000 miles. So that's about double. A little bit less, I guess. Yeah, maybe 2/3 of that and add it. And then this other guy, Deciarchus, comes even closer than that, 33,000 miles, which is about 10,000 miles off. So, I mean, off by a lot, but it doesn't seem like quite a complete shot in the dark. Could have been a lot more ridiculous than that. Except this guy, Archimedes, he really overshot that. That's the size of Jupiter. So my question is, first of all, how do you think the ancient Greeks knew that the Earth was a sphere? We've been talking about that they knew it was a sphere. How do you think they figured that out? A. B, how do you think these people attempted to approximate the size? If you're an ancient person, how are you doing this? Very good. Ships. Good. So if you are standing out to shore, you can actually see ships coming over the horizon. Aristotle talks about this. So that's one. There's actually at least one other major way. Lunar eclipses. The shadow that is cast by the Earth of the sun's rays onto the moon is round. I have a picture here. So even they could tell that it was round. Based also, too, they knew the position of the sun relative to the other stars in the sky, so they did understand that what an eclipse was a shadow of the Earth against the moon. So once they saw that it was curved, that was a major tell. But yeah, the other big one there is they noticed that constellations at different latitudes, different ones were visible. So Aristotle says, there are stars you can see in Egypt that you cannot see on the Black Sea. And that has to mean that there is a curved horizon that we're not seeing past based on your latitude. So so there were a number of these kind of, observations that were available even to ancient people that they were able to arrive at this. So what Aristotle's able to do is he says, okay, so the curvature of the Earth from when I'm standing on the seashore and I'm seeing a ship coming to port, and so he was able to make some approximations of the visibility of ships coming to port, and based on that make a projection of how much further the Earth would have to curve for it to come back on the other side behind him to meet him and make a projection of the size of the Earth based on that. But he was still quite a ways off. He had the right idea, but still was off. So one last kind of set of questions. This is kind of a bit of a more social kind of question. Why would you want to measure the Earth? What are the stakes here? Yeah, okay.
How much is more out there that we can own?
Yeah, no, exactly. No, I was about to go there precisely. Remember, I mentioned we're talking about this enormous empire. This was the biggest empire the Greeks had ever seen. So there's a big question: how big is it actually? In terms of how big is the Earth? I mean, is this actually a big empire relative to the actual size of the Earth? Right? Yeah.
Is this considered the Bronze Age, the pre?
Yeah.
Give me an idea of where we're at as far as that progression.
Yeah. So we are in the Hellenistic period. The Hellenistic period is the period after Alexander the Great dies in 323 BCE, and it extends to the Battle of Actium in 31 BC, when Cleopatra is defeated by the forces of Octavian Caesar. So it is the period in which Alexander's former empire dominates the ancient Mediterranean world until Rome takes over.
So we're past the Iron Age, we're past the Bronze
Yeah.
Age, so we're past those.
Yeah, so the Bronze Age would extend roughly. Actually, this is a shameless plug. University of Cincinnati Classics is the leading Greek Bronze Age archaeology program, kind of ever. Really. There, you may look in the news. There's a new exhibit on a really amazing find that was done by our former department head, Jack Davis, for a Bronze Age gem with engravings on it that are so detailed. We're still actually trying to figure out how it was they were able to manage that in the Bronze Age. But anyway. So Bronze Age extends from about 2500 BCE to 1100 BCE. There was this massive, it's called the Bronze Age collapse. It was literally an apocalypse. All the civilizations in the Mediterranean suffered a major systems failure. Many of them never to be seen again. The only ones that managed to survive are Egypt, and barely. And what would become Assyria, and barely. So at that point, the Greeks lose writing. Again, massive systems failure. They lose writing, literacy, complex city structures. They lose all of that. They have to reconstitute their culture from scratch, more or less. Then that initiates the Iron Age. And then they enter what's called the Archaic Age by about 800. They regain writing from the Phoenicians. And then classical Greece starts picking up around 500. And that's the rise of Athens. That's the periodization. Yeah.
So, sorry, and I'm really interrupt, but I reread Graeber and
Yeah, when The Dawn of Everything?
yeah.
Oh, yeah, great book, yeah.
And so I think they would question that collapse as a true collapse, but as a rejection of what had gone before.
Yeah. Yeah, no, you're correct. And also how exactly we're defining the Minoan and the Mycenaean palace structures is also very much open to debate. Right. So that's a part of the picture. It has to do with how are we defining civilization. Of course, Wengrow and Graeber have their own points about civilization is defined in such a way that really props up our current modern day political structures. So it's yes, but so yeah, that is the case. From the more kind of traditional, standard, mainstream narrative, collapse. Right. Yes. Okay. Wow, that was a big tangent, but it's all right because we're learning a lot about Greek history today. So the question was, why are they interested in the size of the Earth? And yeah, you would say that's a big part of it. They're curious as to how big is the Earth actually, and how big is this empire relative to the actual size of the Earth? I mean, what if it's actually really small in comparison to how big the Earth actually is? There's also systems management, bureaucracy that starts happening. So Alexander was really successful because he took over bureaucratic mechanisms from the Persian Empire. And that requires a really keen sense of geography. So that is also a pretty big impetus as to why these questions are floating around. The world just feels bigger, and they're trying to figure out how big it really is. Yeah.
Wasn't there also a sense of this intellectual glory of like who actually can figure it out? Competition among thinkers and academics at the time.
Yeah. So, as I said, we brushed on the library, the museum. The reconfiguration of all these political sub-empires brings contact with different Greek people to an extent that was pretty unprecedented, which means that, yeah, there's a competition of ideas. There's just a lot of integration and exposure to people, and yeah, I think you're right. That does that definitely drives forward intellectual pursuit too. I would say for sure. Okay, so we're finally getting to the meat of the question here. Eratosthenes' process. So here's a diagram. I do my best to explain what's happening. Eratosthenes heard a rumor, and that rumor was that at this town south of Alexandria called Syene, not to be confused with his town of Cyrene. It's not the same. Syene, so his hometown is to the west of Alexandria. This is south of Alexandria. To his south, there was a town called Syene, and there's this well he hears in Syene. And he hears there's a well where on the summer solstice, the well casts no shadow. You look into the well, and there's no shadow at the bottom of it. Sounds mundane, but what this tells him is that at the summer solstice, the sun's angle, as this diagram is trying to demonstrate, the sun's angle hits, for all intents and purposes, perpendicularly to the Earth. Which means that for him it is, so this is what we call the tropics. That's actually how part of the definitions of what the tropics are. That would be the Tropic of Cancer. So this is very interesting to him because he knows that in Alexandria, on the same summer solstice, there is a shadow. So he puts up some kind of instrument that can measure a shadow on the summer solstice, and it creates an angle, which the diagram labels angle A, or angle alpha, maybe. I can't tell. Maybe that's angle alpha. Angle alpha. So he knows that the Earth is spherical, and as this diagram is showing you, you can project that same angle down to the center of the Earth. There's going to be a mirrored angle if you were to take that same line down to the center of the Earth. And your control there is the sun's rays coming in perpendicularly from Syene. So do we see that the ratio of angle A to 360 degrees is the same as the ratio of the distance between Alexandria and Syene to the total circumference of the Earth? Do we see visually how that works? Yes. So that is his method. Or to put it kind of in a formal way, so the ratio of angle A to 360 degrees is the same ratio as the linear distance from Syene to Alexandria to the circumference of the Earth. If you were to rearrange this, remember algebra? You have to flip it to the other side, right? So you can isolate the circumference of the Earth by taking the linear distance from Syene to Alexandria by 360, divide that by angle A, and that will produce, then you have to cancel out the degrees, but you're left with the distance. That will leave the circumference of the Earth. So this means that in order to figure out the circumference of the Earth, okay, so he already knows 360 degrees, that's fine. But he needs to know that angle, and he needs to know linear distance from Syene to Alexandria. The angle. Unfortunately, trigonometry had not been invented yet. Trigonometry would not be invented until Hipparchus in the mid-2nd century, about 100 years after him. So he would have had to have taken a protractor, measure and measure the angle himself manually from whatever instrument he was using to measure the shadow. Trig wasn't there. I hated trig, so I would have liked to have lived in the 3rd century BC, I think. I would like to live in a world where there wasn't no trigonometry. So he would have had to do that himself. Now, but easy enough. It's not going to be perfect, but, take a protractor, won't be too bad. The linear distance from Syene to Alexandria, that one's going to be a little bit more tricky. I'll come back to this. Yeah, what is the distance to Syene? They do not have Google Maps. How are we doing this?
Did they have surveying, though?
Yeah. So there actually used to be some different theories about how Eratosthenes managed to do this. The original theory was that there were these guys called bematists, and they were trained to have really accurate steps. And like a pedometer, they could just measure distance by counting how many steps they had taken, and they were trained to have extremely precise measurements. And the thought here was that Eratosthenes got a team of bematists, and he sent them walking down to Syene. We no longer think that's the case. It's pretty impractical. There's quite a bit of terrain between Alexandria and Syene.
Visually, it looks like it's a little crooked, but
Yeah, it logistically, it's just kind of a nightmare. So nowadays, scholars do prefer the surveying theory. So actually, in fact, Egypt, the pharaohs have been around. Since the Old Kingdom begins in the 3000s, right? They had a very detailed tradition of surveying in order to irrigate the Nile for the crops and everything. So what we think is that actually he kind of had to do what we had to do and use math. And so he essentially would have had to construct a map from the surveying materials that he might have had access to and construct a model of the distance based on surveying between him and Syene.
Was the compass available at this time?
It was not. That was the Chinese.
Yeah.
Yeah. It was not. So also notice, Syene is not directly south of Alexandria. We'll return to this. So it takes. Here there are some kind of key assumptions that he is operating under here. Number one, this is actually very insightful. He assumes that the sun is very big and very far, because that way he's able to assume that the angle of the sun's rays are happening at a constant rate. That can only happen if the sun is incredibly big and extremely far, and that level of distance won't make a difference in terms of the angle of the sun. So that is very interesting. This also assumes that Syene is due south of Alexandria, which it's not. So we'll come back to this issue. It also assumes that Syene is on the Tropic of Cancer, which it is not. It is close to the Tropic of Cancer. That well just must have been a little bit off kilter. It was off kilter enough. It is close to the Tropic of Cancer, but it's not directly on the Tropic of Cancer. So anyway, part of the issue is we don't actually have Eratosthenes' direct writings. We only have later people from like 300 years after him who record a summary of what he said. And we're just kind of having to, put the puzzle pieces together as to how he did this. But from later authors, it's recorded that he calculated it to 5,040 stades. Okay, what is a stade? We're gonna get back to this, but so and we also know that he got the angle of the shadow with his protractor to 7.2 degrees. So back to our equation here. That makes the circumference of the Earth 252,000 stades. Okay, so what the hell is a stade? A stade, it's actually where we get the word stadium from. A stade is the standard length of the running race in the Greek games. Famously, they invented the Olympics. It was a really big deal to them. And that was the standard length for their race. Except this is antiquity and there is no standardization. Again, we take it for granted, but I mean it's the reason why our imperial US system is so messed up. There's 5,280 feet to a mile, and it's just insane, and the rest of the world thinks we're crazy. It's the same deal. The ancient world had even less standardization. Theoretically, a stade is the standard length for a Greek race, but that was difficult to control. Every major region of Greece, if you had an area where they were doing games, had their own stade. Now, thankfully, we have Pliny to help us. Pliny says that Eratosthenes' stade was 300 Ptolemaic cubits. This means that then we have to figure out what a cubit is. Now this is helpful because we can do archaeology on Ptolemaic buildings. We haven't done, as I mentioned, we haven't done a lot of archaeology in Alexandria, but we have done some. And based on that, we have other records saying this is how big these buildings are supposed to be. We can deduce the length of a Ptolemaic cubit to 0.525 meters, which would make the Egyptian stade 157.5 meters. And if you calculate that by 252,000, that gets you to 39,690 kilometers, which is 99.04% accuracy to the math that we now have for the circumference of the Earth. Now, a lot of, because academics, their job is to be pedantic, and if they don't have papers to give at conferences, they feel that their life has no purpose or meaning, and so they have to create extra work for themselves. There are scholars who are trying to dispute this and say, well, Pliny mentions other stades. Eratosthenes is not actually from Alexandria, so are we really sure that it's the Egyptian stade that he's using? There are just many other types of stades that we know are around. This is an issue having to do with, so we're measuring the Egyptian stade by kind of deducing it from Egyptian buildings, but Pliny says he measures the Egyptian stade by comparing it to a Roman mile. But then we also have independent evidence for what a Roman mile was, and if you use that, then it's actually 184.98 meters. And then that would mean Eratosthenes is off by 16%. So there is scholarly debate about this. But yeah, so there's this other geographer, Strabo, and he measures the distances between he's writing in the Roman period, and he records the distances between different cities in the Roman Empire. And there's been a scholar who has done a systematic analysis of all the distances that Strabo has done and compared them to the real geographic distances using satellite imagery and such. And it would seem that there just was not agreement on what a Roman mile was, because if you use Strabo's version of what a stade is, that gets you back to the much more accurate calculation, and that gets you back to Eratosthenes being within 99% accuracy. I mentioned that Eratosthenes didn't know that Syene wasn't due south of Alexandria, and that it was not directly on the Tropic of Cancer. This is a really fortunate accident of history, because the reason why he still got within 99% accuracy is that those two mistakes canceled each other out. It really is astonishing. I don't know. I don't think that any scholar has kind of gone out and said this. I wonder if maybe he did know that it would end up canceling itself out, but probably he didn't. I couldn't tell you. But yeah, if I could refer you to the book that talks about this, but if you do that math, the reason why he's able to get within that accuracy, besides those two mistakes, the fact that he made those mistakes, is because they happen to cancel each other out. So yeah, his impact, that meant that for the rest of history, in both Europe and the Islamic Golden Age, and intellectual advancements there, we for a very long time had a pretty accurate knowledge of how big the Earth was. And in fact, Aristotle, even on his assessment before Eratosthenes, he says the Earth isn't actually that big. The ancients actually had a pretty, there's that Carl Sagan, we live on a pale blue dot kind of thing that he had. Even the ancient Greeks kind of had that sense as well. There's a really fantastic passage in Seneca's epistles where he said, get some perspective. Imagine you go out above the Earth and go farther and farther, and it'll look so small. So Seneca was doing the Carl Sagan thing, 2,000 years before he was. This goes to an issue that I mentioned before, which has to do with Christopher Columbus. Christopher Columbus, he was, he was looking for an alternate passage to Asia. He had a really difficult time finding funding. He went across every court in Europe because because Europeans knew how big the Earth was. They knew it was not logistically possible to, and they didn't know that the New World was there, so they knew it was not logistically possible to sail that far. You just couldn't carry that many supplies that could last you that long directly to the other side. Columbus disputed Eratosthenes and thought that the Earth was smaller and that, therefore, it wouldn't be as difficult as Eratosthenes' model would say to get to the other side. He had a really difficult time obtaining funding. Ferdinand and Isabella finally said, okay, this is just kind of a cheap shot Hail Mary because we're fighting against Spain and England. It's extremely expensive. So, okay, I mean, whatever. We'll just give him this guy, this idiot. they thought he was an idiot. These ships to sail on the other side, why not? And but it was only because Columbus disputed Eratosthenes' very accepted model for the size of the Earth that he decided to do that. So that's kind of the legacy of that history. This is probably less relevant for you all, but this is a plug that I'm required to make by my department. If you know people who are interested in undergrad at the University of Cincinnati, we offer full ride scholarships to classic students, qualified classic students. So that information is available for you if there's anyone in your life who's interested in that kind of thing. Are there... How much time do we have? Okay. Are further questions? This can be really anything.
Yeah.
How about you? I haven't heard from you.
Sure. So we have the whole thing of the Columbus journey wasn't really thought feasible because they had a semblance of how long that distance would be.
Yeah.
Given how much distance was relatively well accepted, were there any thinkers, whether in the Hellenistic period or beyond, that ever speculated there might be more land out there that we're not, because there is space?
So that there was actually. That came from this kind of idea that it actually kind of comes down to Aristotle. He was the philosopher of the golden mean. There was this fascination with the idea that everything needed to be balanced. So they knew that there was this kind of landmass that they were on, but they thought that things needed to be balanced. And so there were theories that on the other side of the Earth, there must be a similar sized landmass. That the North and South poles also needed to be balanced. So they didn't know about what we call Australia, but there was an idea about an Australia. Australia means southern continent. They assumed that there must have been an opposing continent in the southern hemisphere to balance out the northern hemisphere. They just didn't know what that was, but they were really obsessed with balance, and that this goes back to the celestial spheres thing. It was the idea of the prime mover. God is kind of behind it all. God gets the planetary spheres rolling. So at the end of the day, they thought everything needs to be balanced because there's providence behind it. So, yeah.
So then, was part of Columbus's challenge that from the beginning, that there was not a balancing landmass, or was it just if there is, I'm probably not going to hit it kind of thing?
I think I might need to look into this a bit more, because my understanding is at least at his own contemporary times, it was mostly taken for granted that that was just kind of empty ocean.
Those maps with here there be monsters.
Yeah. There might have been speculation that... Yeah, there might have been ancient speculation that there would have been another landmass over there, but because they didn't know anything about it, I just don't think that they really cared too much. I think they were mostly operating under the assumption that it was empty.
That part of the theory kind of fell off with
Yeah, I'd have to look more into it. I'm more familiar with the idea of a southern hemispheric balance. That was a bit more common of an idea. It also had to do with the fact that they knew that sub-Saharan Africa must have been something. So maybe that's why they were a little bit more into the southern hemisphere landmass theory. I'm less sure about the other hemisphere from the other side. Yeah.
So he makes this grand calculation, right?
Yeah.
And he's a confident guy, right? So what does he do with it? Does it help him or anybody else right around him in his time frame to better understand the scale of Africa, the scale or the distances to maybe the Indus Valley, or is it put to use in any way to help make the known world, that little circle they had, just bigger?
So educated people would have known that. Yeah, because we do have those writings. I'm as I mentioned before. I mean, we already have Aristotle saying, actually, no, the Earth isn't all that big. It's just that the logistics of seafaring. Again, we take it for granted with the Suez Canal and what have you, but it's really quite difficult to do that kind of circumnavigation. Yeah, it wouldn't happen until Magellan. Although there were some Chinese explorers who did some pretty distant navigation. The Polynesians managed to get pretty far as well.
He had that base.
Yeah.
Understanding. He couldn't apply it to, or it wasn't applied, at least theoretically, mathematically, to say, hey, if we know the circumference of the Earth, then we know that Alexandria to this has to be this distance, at least mathematically.
Yeah.
There was nobody did that kind of calculation. Now that they were able to understand circumference.
No, that would actually have been done by Ptolemies, not King Ptolemy. Ptolemy's Almagest. That was actually kind of the best science after him that they had for geography, the size of these land masses. And he wasn't that far off either. The issue was, it was actually more a political question. Alexander the Great did something. I mean, great man theory of history is not a good way of thinking about history. But at the end of the day, Alexander really did manage to pull off something that just would not be repeated. And so that level of imperial expansion just did not happen after him. And after Alexander, India ended up just being kind of a political limit to what kind of access people had to see the world. Well, from the other direction. Yeah, from the other direction.
He did a pretty good job, didn't he?
Yeah. Well, I mean, I guess you have to make the span. Yeah. No, that's from a Mediterranean perspective. If you're going from the Mediterranean in that direction, India was kind of with the trade routes, with the way that you could get there. That was it. Just that, and that was the legacy of Alexander.
I understand, even if they could do calculations, and maybe they did,
Yeah.
they didn't carry much weight because it sounds like it would have to have been confirmed or somehow done physically.
Right. Right, and that required establishment of trade routes, and that becomes a political, that becomes a political issue. Yeah.
Well, the amount of time it took to find the head of the Nile.
Yeah, that was not
Recent.
that was that on the late 19th, I guess. Yeah, late 19th. Yeah.
How quickly did this knowledge take hold and migrate around the size of the earth?
Yeah, so, I mean, it depends on... So the Library of Alexandria... So he's at the Library of Alexandria as he's doing this. The Library of Alexandria was kind of the cultural powerhouse for the Hellenistic world as they knew it. So he was in as good a position as anyone to have that information. It was a very international city. People were constantly coming in from other areas. So, he would have been as good in a position to have that knowledge spread as anyone I can think of. So,
How many people were literate? I mean, how many people would have encountered that information?
oh, this would only have... these are all extremely elite Greek guys. I don't know, let's be very clear. There is if you really want to get into the weeds and you want to do dissertation on ancient literacy, there are tons of people who do this, who try to do this, then the other, and try to say, okay, literacy was at 5%, but wait a minute, what do we mean by literacy? We actually don't even know what literacy means in modern times, and it's a sinkhole. So it depends on what you mean by accessible. Accessible on the level of if you are the kind of Greek male, property-owning Greek male who has the time and leisure and resources to be able to go to the Library of Alexandria, it was 100% accessible.
How long it took for that information then to make it over to the Persian? Because after Alexandria's library faded in prominence, it was really the libraries in Persia, right, that kind of became more of a powerhouse of. And so, did that information, or did they redo it all themselves? Do you know?
So this is not my area of expertise. I would assume that the Islamic Golden Age scholars knew these figures. I cannot imagine why they wouldn't.
Right. Was it a transfer of information, or did they redo it? Obviously.
It's not necessarily a transfer as much as it's just how empires rise and fall towards the end of antiquity. So the Byzantine Empire starts to fall apart at the edges. You have the Umayyads and the Abbasids coming and going. And so they're not... So someplace like Alexandria, Alexandria is Alexandria, that knowledge is there, but then different kinds of regimes are going back and forth over it by late antiquity. Eventually, the Library of Alexandria, again, as I said, the Library of Alexandria is a temple to the Muses. That becomes a problem once Christianity takes over. So once Christianity becomes established as the sole legal religion, that means the end of the Library of Alexandria as an institution. But that information, we have it. We have this record because there's then a medieval tradition of manuscript. So you have these monks in their scriptoria, and they're copying down the manuscripts. So they're able to preserve that information into the medieval period.
I was just wondering, like, if there was a transfer of that information into the Persian area. I don't know at the time the equivalent.
Okay. So going back to this map. So you mean in Eratosthenes' time?
Yeah. Or
So.
within a couple hundred years, because again, that part that as you go east, that becomes a powerhouse and the center of knowledge, if I remember correctly, after sort of the waning of Alexandria or so forth. So where you have that Sela.
Yeah. So the Seleucid Empire is a Greek empire. So so Alexander conquers all this territory, from Greece through modern-day Turkey, through Mesopotamia, through modern-day Iran, through Pakistan. That all becomes a Greek empire. So what was formerly the Seleucid Empire, that does not become, that remains Greek for quite some time. That requires, because after the Greeks, as I mentioned, the Romans take over most of what was formerly Alexander's empire. So after the Seleucids, that became part of the Roman Empire, which meant that that would become what we would call the Byzantine Empire. But then the Byzantines eventually do lose that territory. This then becomes the thing, as mentioned, people like the Umayyads, the Abbasids, who are coming in, and they establish the rise of Islam, and the caliphates is what really knocks that down. And that gets you into the Islamic Golden Age, but those people all have access to these texts. Yeah. Yep.
So kind of, connected to that a little bit, when Eratosthenes came up with this, this number, was it just basically accepted from then on, or were there competitors after him who said,
Yeah.
he was wrong and made other numbers?
Yeah, to my knowledge, it was not substantially challenged, because Ptolemy's Almagest really becomes the standard geography after him, and Ptolemy's Almagest more or less takes Eratosthenes' measures mostly for granted, and then that becomes a standard through even the medieval period. So yeah, overall, maybe I would have to look into it, but so far my understanding is that Eratosthenes, it kind of just became what you would call orthodoxy.
Another level of accidents in that not only did he get a number that was very close, but that he was also at the Library of Alexandria.
Yeah.
And Ptolemy was there.
Right.
And someone who could disseminate that knowledge was there as well.
Yeah. It doesn't work too much differently than it does today. You have political institutions that set the tone for what is correct knowledge. And those things are very difficult to dislodge. And it becomes a political question in order to dislodge those issues. So if you have these kinds of regimes that, just institutionally, like the Library of Alexandria, but whatever kind of successor institutions that carry that information forward, to question that becomes a political stance, which is why Galileo gets in trouble, right?
But so what's the contemporary version, the binding?
I don't know, like vaccines maybe? Yeah, I guess it's like vaccines. I guess RFK is there to shake that up. I don't.
Instead of the Alexandria Library,
Harvard again. That's why they're attacking Harvard. Because these institutions set the tone for what knowledge is, what you are supposed to know, and what is correct and what is not, and that's really a political question. Yeah. Great. Thank you so much.
Thank you. That was very informative. I'm also reconsidering all the random notes I have from life that are still hanging out in my house and what a future researcher is going to get from them. So thank you all for coming here. You can follow us on Facebook or on Meetup, Science on Tap Cincinnati. As I mentioned, we do this the first Wednesday of every month. Next month on Wednesday, July 2nd, the EPA will come back. I left my Post-it on the table. Of course I did. Biologist Shannon Griffin will come and talk about the spit test for a healthier planet and how they can use the EPA is doing research on saliva and what it tells you about environmental risks So I'm not sure how we're going to get from spit to environmental risks, but it'll be a journey. So I hope you'll join us for that. Thank you all for coming. Have a safe trip home.